Assalamualaikum and hi. We are from Group 12. We will present Chapter 10, PW section, and PW. So our group member is Clarissa, me, Nur Amira, Siti Nusahila, and Muhammad Khalid. The content of our presentation today include definition, NPW criterion, component of NPW, example 1 and example 2. Let's look the definition of NPW. Network present is the sum of the present values of all cash flows associated with an investment, including initial outlays and future inflows and outflows, discounted at a specific rate, the required rate of return or MARR. Let's look NPW criterion. Step 1. Determine the firm desired return or interest rate on its investment. The interest rate used let symbolize the rate at which the firm can always invest money in its investment pool or the amount of capital accessible for lending and investing. This interest rate is also known as the needed rate of return or the minimum attractive rate of return, which is MARR. This is sometimes referred to as the cost of capital in the business community. Typically, this peak is a policy choice made by upper management. The MARR may alter during the course of a project, but for the time being, we shall calculate present works, PW, using a single rate of interest. Step 2. Estimate the service life of the project. Step 3. Estimate the cash inflow for each period over the service life. Step 4. Estimate the cash outflow for each period over the service life. And step 5. We determine the net cash flows for each period by using the formula net cash flow equal to cash inflow minus cash outflow. And step 6, we can find the present worth of each net cash flow at the MARR. Okay, and then after we get NPW, if NPW is larger than 0, which means we get positive value, we accept the investment. If NPW equal to 0, its mean remain indifferent. And if NPW is smaller than 0, which is we got a negative value, we reject the investment.
And now we'll be talking about the components of the NPW or the net worth present. So first of all, the net worth present is equal to the summation of the cash flow or the CFN divided by 1 plus or all to the power of n minus the initial investment. And n here is the number of period, and the r is referred to the discount rate. So first of all, the CFN or the cash flow refers to the funds spent or gained for the benefit of the investment, such as capital expenditures, interests, or loan payments. Meanwhile, the number of periods, which is n, it refers to the number of periods, means how many months or years the project or the investment will actually last. And the discount rate here represents the company weighted average cost of the capital. And the WACC includes the company's interest rate, loan payments, and dividend payments. So the net worth present is equal to the cash flow 1 divided by 1 plus the discounted rate, all to the power of 1, which is the first period, and then plus the second one, just exactly the same, except it's to the power of 2, which is the number of period, again, second month, third month, and so on, minus the initial investment.
So now I will explain for example 1. So for example 1, the question is that we were given the required initial investment, which is equal to 1.8 million. And then we are also provided with the projected cash savings over a 7-year project, as we all can see in the picture, where we are given the end of year and also the cash flow. So the end of year 0 indicates the initial investment, which is 1.8 million. So the question is that the president of the company is asking us to evaluate the economic merit of the acquisition, which means that we need to evaluate either this project is acceptable or not. So this evaluation can be done by determining the NPW value. So lastly, we're also provided with the firm's mark, which is 15% per year. So for the solution, we can directly use the NPW formula. And again, we are given the initial investment equal to 1.8, and then the R we can obtain from the firm's MAR value, which is 15% per year, so it is equal to 0.15. So for that, we can just substitute the value from the table of the end of year and also the cash flow into the formula, and we will get the final answer, which is 1.5 million. So as a conclusion, the project resulted in a surplus of 1.5 million, which means the NPW is more than 0, so the project is acceptable since the project is returning a profit that is greater than 15%.
Next, we move to the last part, which is the example 2. So this example 2 says that two technologies are currently available for the manufacture of an important and expensive food and drug additive. The two can be described as follows. So now we have two laboratories, which is Lab A and also Lab B. So Lab A is willing to release the exclusive right to manufacture the additive in the country for 50,000 payable immediately and 40,000 payable each year for the next 10 years. The production costs are 1.20 ringgit per unit of product. The Lab B says that this laboratory is also willing to release similar manufacturing rights. They are asking for the following schedule of payments, which is on the closing of the contract, 10,000 ringgit. From year 1 to 5, at the end of each year, a payment of 25,000 each. And from year 6 to 10, also at the end of each year, a payment of 20,000. The production cost for this laboratory is 1.37 ringgit per unit product. So neither lab is to receive any money after 10 years for this contract. It is anticipated there will be an annual production of 100,000 items for the next 10 years. On the basis of analysis and trials, the products of A and B are practically identical in quality, assuming a MARR of 12%, which lab should be chosen. Calculate NPW. So for the solution, the first one is we need to calculate for NPW for the lab A. How we can get 163,000 is by multiply 1.23 with 100,000 units. So after that, we need to add with 40,000 ringgit, which is the payment for each year for the next 10 years. So as we follow the formulation, we need to divide it with the 1 plus MARR and power with the current year. So after we add all of this for the next 10 years, we need to add with the payable immediately, which is the 50,000. So for the NPW Lab A, we can get 970986.35. And the next one is we need to calculate NPW for the Lab B. How we can get 163 and 162,000 and 157,000. So the first one is we can get 162,000 by multiply with the cost for the per unit, which is 1.37. We multiply with the 100,000 items. So after that, for the first 5 years, we need to add with 25,000. So from that, we can get 162,000. For the first 5 years, we need to use that value, which is 162,000, and divide with the MARR with the power of the current year, with the year for the first 5 years. And then for the next 5 years, which is year 6, 7, 8, 9, and 10, we need to multiply the 100,000 items with the 1.37 ringgit per unit and add it with the 20,000 ringgit. So we can get 157,000, and then after we multiply, we add all of this. We need to add with the immediate payable immediately, which is RM 10,000. So after that, we can get 915,108.9. Thus, we choose laboratory B because it is more safer. So I think that's all from our group. Thank you.